Alrighty, so let's go ahead and get our client project all up to speed so that we can go ahead and write our login system. So, to do that, we first have to open Unity. I want to point out that there has been a couple version updates in Unity, so make sure you grab a 5.3.1 to do this. There were a couple API changes that we're going to be taking advantage of in this video, so make sure you do that. So I'm going to go ahead and open up the client project. And the first thing I'm going to do preemptively, the first thing I'm going to do is I'm going to fix my versions for the DLLs, the Unity or the Photon DLLs. Now, if you open this, you'll obviously see a bunch of errors. We changed a whole lot of stuff, so we're going to definitely have some problems. But let's go ahead and fix our DLLs first. So this is just a heads up for anybody who runs into an issue where you get seemingly random errors that are internal to Photon and not part of your user code. A potential issue is you might have some weird library stuff out of date. So if you recall, all the way back whenever, we created this lib folder that has its Photon client.net and Photon client Unity, and it's very simple to see if this is your problem. So if I open up Photon client.net and open up on my Photon installation folder. Now, this is the Photon installation folder of the version of Photon that I'm using. Now, that's very important. And come over here to lib and look down here on photon3.net. Simply checking the size will be a big indication that you're using the wrong version. So the version that we have installed here is 120 kilobytes, whereas the version on the server is 129 kilobytes. So that means we just have to recopy over these files. So I'm just going to plop them over here and replace them. And then we do the same thing for Photon Client Unity. Photon 3 Unity DLL through XML. Replace that. And might as well just check our server real fast. So our Photon socket server is 221. I'm pretty sure I already did this for the Photon socket server. Yeah, I did. I think I did that off screen. But I just wanted to point that out as a tip if you guys get some random errors. Okay, so on to Unity. So we have a bunch of errors. So I'm going to go over here, right-click, and hit Open C# project. And I think the Unity integration with Visual Studio is getting a lot better. There's the Unity tools for Visual Studio that you can go ahead and grab. I highly recommend you download them. And furthermore, it seems that launching Visual Studio from the project window seems to work more often than it doesn't, as opposed to previous versions of Unity, which, I don't know, there was like just a random chance that it would do practically anything when you right-clicked and open C# project. Sometimes it'll do mono develop. Sometimes it do the wrong version of Visual Studio. Sometimes it would just open a random file. But I think it's mostly been fixed pretty well. Okay, so for most of our errors are going to be in our game context. We're going to do this last because our game context is going to be where we're going to make a bunch of changes here. Now, for the player module, we have some stuff here, but for the player module, what I really want to do here is I just want to take all this code and nuke it. Now, we're keeping the player module, but it's just going to be a public abstract class, and we're going to get back, come on, there you go. We're going to get back to this class later, it's because it is important. And now let's look at our systems. Our login system obviously is not going to work for a variety of reasons. Our namespace changed here, and also it no longer implements these interfaces. So we can go ahead and nuke the entire, remember that code that we wrote just to test things out? We're going to nuke all of that. And then I'm going to hit Alt-Enter to bring in the assets code infrastructure systems namespace. And then I'm going to come over here and implement the single method. I'll leave it as throwing for now as a reminder if that method gets invoked before we implement it. But the single member that we need from the iLogin system client, the debug set available players. For infrastructure, I kind of want to move these classes into this namespace. So I'm going to do that. And then I'm going to Control-Shift-R and say adjust namespaces. You can also do this manually. I just want to do that because, well, I was getting tired of... I really don't like having a bunch of folders in this unless they're absolutely necessary, because it makes doing the videos a little difficult where everything is so far indented. Now, as you can see in Unity System Base 2, because we changed the namespace for iSystem Base, we have to make sure and... Oh, wait a sec. No, we didn't. What were you yelling at? I think ReSharper is just confused. Okay, Unity System Factory. Since we did change the namespaces on these, I'm going to go ahead and Alt-enter these guys in. So we're now importing I don't know which one came in. I think it was Buzz MMO base. So now the namespaces here are correct. So now at this point, just looking through these files, there's only a couple files. Looking through these files, it looks like the only errors left is in the game context. So the game context actually is going to be a little different now. I've kind of came up with a clearer separation of concerns for what the game context is and how we can use it to very cleanly separate the connections between the master server and the game servers. So there are changes coming to this class. I'm just going to start off by nuking pretty much everything but configuration, and then I'll Alt-enter that in. So that's BuzzMMO base is the configuration class, and then I'm just going to nuke everything after our basic configurator. And for start, I'm going to go ahead and, well, actually, you know what? Just kill all of this stuff. Basically, at this point, I'm going to move this stuff off to the side here, because we'll be using it later. I'm just going to nuke everything. So our game context now just looks like this. So that's what we're starting with. It's just a lot easier for me to just nuke it all and show you guys what we're gonna make this. Anyway, the game context, the responsibility for this is sort of to be the entry point into our system, where we can access all like global objects, things like our configuration, or what currently active player module there is, and so on. We'll also use it to store information such as what user is currently authenticated, or if they're authenticated, what roles they have. We're going to also put in stuff here later down the road for things like being able to easily instantiate prefabs. There's this prefab and actor system that I put together for off-screen a while ago that we're going to be implementing, which we're leading up to. That will be the responsibility of the game context. So think of the game context kind of as the entry point, or a poor man's IOC container, or whatever. But so that's what the game context is. The player module, I'm moving its responsibility here. Originally, the responsibility of the player module was that it was kind of we had these modules that we could add into our transport. So we could say, okay, so the player module has systems and other things, and we might have an actor module or a world module that does different things, and they all kind of connect into our transport. I don't want to do it that way. From the game context, I want there to be a one level of abstraction between the game context and the player module. And basically, the reason for that is we don't want to couple our transport to the game context, because our transports are going to change. We're going to connect to the master server, then once we find a game, we're going to disconnect from the master server and connect to a game server. And in theory, in the future, we'll have multiple servers to connect to for whatever reason, maybe reporting or counters or logging or stuff like that. So we want to have the game context be a little bit more flexible than what it was before. So the game context is no longer going to own the concept of the transport. That's going to be a thing that's going to be swappable between our different situations that we might find ourselves in, be it that we're connected to a game server, connected to a master server, or connected to multiple game servers. For example, you know, if instead this was an MMO where where region servers just, you know, dealt with a square bit of land, once you hit a corner, you're going to have to connect to 2 region servers at once, and that would just be super messy if the game context had to figure out all these different scenarios at once. So we're moving that into a different class, basically. And I don't know, I'm terrible with names. I kind of wanted to call it something like Connection Manager or something to that effect that represents all of the different individual modules that can be added in and connected. So the Connection Manager would be responsible for things like, well, connecting to servers and then delegating what the servers tell it to modules, and then the modules will do different things. So the player module actually would mostly be going away, because then what we're going to do instead is we're going to have our systems module instead in this case, and then we'll have something like an actor or a world module to deal with world connections and so on, and then we can mix and match different modules in different server connections. So we can go ahead and nuke the player module, and then in infrastructure I'm going to create a new interface, And I'm going to go ahead and call it... oh, I already forgot the name that I chose for this. Again, I'm terrible with names. I when I kind of put this together off screen, I was like, I'll defer, naming this thing until I kind of figure out where I'm going with it. And then now I'm recording the video and I'm like, wow, what name should I give it? Remember the 3 most difficult problems of programming: naming things and off by 1 errors. I think it was Connection Manager. That's such a bad name, but you know what? Whatever. Okay, so Connection Manager is going to have a void update method, which will be called from the game context, a deferred initialize method. Now, I'm calling it initialize and not connect because it's not necessarily going to be connecting to a server, I guess. I mean, it is called the Connection Manager, and it will always be connecting to a server, I guess. Maybe I should find a better name for it. But I call it initialize. Initialize means, get everything up and running. So I guess not only do all of your connections to the different servers, but make sure that we are all initialized and we have all the data from the server that we need. And then so this deferred will be marked as a successful one once that finishes. And then we're going to have a deferred destroy method. Okay, so let's hop back over to the game context and kind of flesh it out a little bit. So jumping back to the game context, we are going to go ahead and I'm going to go ahead and give it a couple properties. We'll do an connection manager. Now at the moment, this is going to be get protected set. I'm doing this kind of as a looking in the future sort of thing, because when we go about creating a in-memory test, we're going to do that by subclassing the game context and changing the behavior of the connection managers and how transports are made and all that fun stuff. So I'm making it get protected set. Now I am making this a public property, though, a public access, a public getter, so that other systems and stuff can get access to the connection manager and cast it into whatever connection manager is appropriate. So then we're going to have an iConnection manager. We're also going to have a iSerializer serializer, so that's going to be public as well. And you know what? Maybe I'll move the configuration store on top because we're going to initialize it in that order. We're going to initialize the configuration first, then the serializer, and then the connection manager. So let's scroll down here. And after we configure the configuration store and the log, let's go ahead and let's put in I'm going to put in some separators here. Kind of like doing this for longer methods, especially methods that do a lot of initialization. So this is our configuration. And next up we have our logging, which, whoops, I missed that by a couple lines. Then after that, we are going to have our top level objects. So serializer equals new simple serializer. So our top level objects are things like the object that's responsible for containing our authentication data and determining roles and permissions, or it might be our prefab system, how we're going to instantiate actors and all that fun stuff. But for now, we just have the simple serializer. And then after that, we're going to have some command line initialization, but we're not going to write this yet. We're going to write this in a couple videos. The command line, what we're going to do is we're going to write a really simple sort of thing that's going to parse out the command line so that we can get our tokens that are set by the launcher to do the actual connection and authentication with. But we'll leave that as a to-do here. Then I'm going to make a public virtual iClient transport, create transport, that takes in a Photon server connection, and it's simply going to return a new Photon client transport connection. Now, I'm not entirely sure how or who should necessarily have the entire responsibility of creating transports, but I'm leaving it here. I'm putting it in the game context because I can't envision a time where we would have multiple kinds of transports. And if we do have multiple kinds of transports, then we would have multiple kinds of Photon transports and multiple types of in-memory transports. And I'm marking this as virtual because, like I said, when we do the in-memory stuff, we want to be able to subclass out game context and override the behavior of how transports are created. So that's why I'm putting that in here. It's unfortunate that we're going to always be accepting a Photon server connection for a interface type, but it doesn't really matter because the only two alternatives that I see are either we're using Photon or we're in memory. And obviously, this code doesn't really rely on the Photon API directly, but one of my goals here is not to abstract out Photon entirely from the system. I'm not trying to do that, but with the way things have been written, it would be trivial to change it from Photon to, let's say, RackNet or something like that. Anyway, next up we have our Unity events. So I'll mark this like this, Unity events. So for our Unity events, we have a public virtual void start. And this is going to call a method that we haven't written yet. And it's going to be called connect to master server. So we haven't written that method yet, but we will here shortly. Public virtual void update. This is simply going to say if our connection, if our current connection manager is not null, then connection manager.update. So we're kind of deferring this, deferring the ability to update to that. Now, ReSharper is going to tell you to use the null traversal. What is it called? I should know this. I always forget the name of it. Null propagation operator. But again, although this would work in our MMO Buzz MMO base project that's targeting .NET 3.5, it won't work in our Unity code because our Unity code is being compiled with the version of Mono that doesn't have that feature yet. So then we'll do public virtual void on application quit. And here I'm simply going to say if connection manager, if connection manager does not equal null, then obviously connection manager dot destroy. Okay, so those are our Unity events. Next up, we have our connection manager factories. So I decided to make it instead of being able to just say, ooh, create this connection manager and instantiate it directly whenever you want to switch between something like the master server and the lobby, I thought it would be simpler to create these little connection manager factories in the game context, because there's most likely only going to be one way to connect to the master server or one way to connect to the game servers. This is something that's subject to change, but this is the simplest solution that I came up with, so we're going to use it. Public void connect to master server. All right. So for his implementation, it's going to be a little weird. I am going to go ahead and make this... Well, no, I can't make this deferred yet, because we have to actually create the class for our master server connection. Now, to do that, I'm going to create a new namespace called master server, and I'm going to basically plop most of our master server specific code inside of this namespace here. So our systems, our master server systems, and all that fun stuff. And then I'll move systems up into here, and I'll adjust the namespace. So, of course, that changed our login system to use the master server.systems namespace. Now, again, we are getting a little higher up in the amount of indentation that I would like, but I don't really see many other ways to organize that code, because I really want the master server and the region or the game servers to have a very clear separation of which code is for which server. And unfortunately, the only tool I have to do that is going to be using namespaces. Okay, so to connect to master server, let's go ahead and create our master server connection manager, which will simply inherit, or implement rather, iConnection manager, which of course comes from the assets code infrastructure. And we'll just go ahead and we'll leave the implementation as it is. So we have the three methods, and they all return, or they all throw not implemented. So for connect to master server, I do want to return a deferred of master server connection manager. And the way I'm going to write this is going to look a little funky. No pun intended. So we're going to have a func of a deferred of a master server connection manager. The reason I'm doing this will make sense shortly. Called connect, which is simply going to be this nice little delegate here. Or a nice little closure here. And what we're going to do is we're going to say var manager equals new master server connection manager, and we're going to pass in the game context as a constructor parameter. Now, I know the constructor of this class doesn't yet have that parameter, but it will here in a second. Then I'm going to say connection manager equals manager, and then I'm going to say return manager dot initialize, then empty no parameter lambda deferred dot success manager. So all this this function does here is it returns a deferred of master server connection manager, and when that deferred resolves, then it will return the manager that was instantiated. Then what I'm going to do, so the reason I made this a closure will become very apparent here in a moment. I'm going to say if connection manager does not equal null, then connection manager dot destroy, then connect, otherwise connect. So there are two cases here, really. If the connection manager is not null, we first have to destroy it. Make sure it's disconnected. Make sure it's done all its cleanup, changed scenes, done any asynchronous work that needs to be done, because we kind of want connection managers to be just one active at a time. I'll clarify that in a moment here. And after it gets destroyed, then we connect to the master server. And because of the signature, this is a func that returns a deferred, the deferred returned here will be a chain of first destroy, then connect, then resolve. Otherwise, we just invoke our func directly. And again, this really is starting to show the power of our nice little deferred API. Now, as far as multiple connection managers being open simultaneously, that the way I'm architecting this right now is we're going to have a single connection manager at a time. That isn't to say we'll have a single connection at a time, because a connection manager can open up as many as it wants to, but we're only working for the case that we have one connection manager open. I don't see any practical reason to allow multiple to be open at the same time, nor do I see it to be very difficult to change the code to allow multiple to be open at the same time in the future if we need that capability. But right now, I'm just focusing on simplicity. Anyway, so that's our connect to master server. Obviously, this code's not going to compile yet because we don't have that constructor parameter, but we'll do that once we get done with this class. Next up, I want to create some nice, this handy little convenience methods. So we're going to do scene loading, and I'm just going to write the method stubs first. So we're going to have a public deferred load scene string scene name, a public deferred load scene string scene name, and then also load scene mode, which comes from the Unity Engine.scene management namespace. So make sure you import that at the top, mode. And then we'll have a private IEnumerator of load scene co that takes in a deferred. We'll just do def string scene name and load scene mode. So you can probably see where I'm going with this. Basically, I wanted to change the asynchronous scene loading concept into using our deferred API so that we can chain the concept of loading scenes with the concept of being able to talk to the server or invoke some system method or something like that. So by doing this, it's just really small wrapper, but it'll clean up our code substantially later on. So our load scene method that takes in one parameter is just going to defer to the one that takes in two parameters, with the second parameter being single. By the way, if you're not familiar with the load scene mode or the new scene API, load scene mode.single is equivalent to load level async, or load level, whereas load scene mode additive is equivalent to load level async with the additive parameter sent to true. Anyway, so our two parameter guy is simply going to instantiate a deferred, so def equals new deferred, and then he's going to start a coroutine passing in load scene co of def scene name and mode. Then he's simply going to return def. Oh, whoops. The load scene has to return load scene, so make sure you do that as well. And then for our coroutine, we're simply going to do yield return scene manager dot load scene async, passing in our scene name and our mode. And then I'm simply going to say def set result true and null. Also, it's saying that I can make this static, so why not? Okay, so again, very simple, straightforward wrapper around the concept of loading scenes. That will clean up our code. So now we're going to have to move on to the master server connection manager. So what is the responsibility of this guy? That name is so long. Okay, I'm renaming it. We're naming it to master server. Connection manager is implicit. There we go. That looks a lot nicer. Those scroll bars, those horizontal scroll bars, I can't stand horizontal scroll bars. Anyway, so we have our master server class, which is a connection manager. And his responsibility is simply to load up different modules and do other master servery things, and also create the transport. So let's go ahead and create his constructor. His constructor is going to take into game context. And I think I'm going to go ahead and make this protected and rename it. I don't see any circumstance where I would base class this out. Well, then fine, just leave it as private. We can make it protected if we ever run into a situation where we need to subclass it. Again, I'm really forward thinking about how we can clean up our systems API so we can run the server code, or not all the server code, but the server's infrastructure on the client. But I don't think it would be necessary to subclass out master server, so I'm going to leave it as is. Okay, so next up, we're going to go ahead, I'm going to say var config, or masters, I'll just say config, why not, master server's implied, is context.configuration. Remember our awesome configuration class. Master server. Oh, come on, stop doing that. And I'm going to say var address is config at address to object string. And then var application is config application name dot to object string. Now that we have that, we can go ahead and create our transport. So I'm going to start off by creating a private read-only iClient transport, and I'm just going to call this transport. And say transport equals new Photon client. Whoops, no, I don't want to do that. I want to say transport equals context create transport, passing in a new Photon. Whoops, come on, Photon server connection of address and application. And yeah, so okay, at this point in the constructor we would initialize our systems module. I'm not going to do that quite yet though. I want to finish out this class first because our systems module is going to be another class. What are you yelling at? This field is always assigned before being used. What are you talking about? Oh, can be converted to a local variable. Derp, I don't care. It can shut up. Okay, so for update, all we're going to do is do transport.service, and that's it. Now for our initialize is what happens when we want to switch to the master server. So what do? Well, the first thing we're going to do is we're going to load the login scene and then connect and then do on success. Now, if we are already authenticated in the future, I might change this to where we immediately just jump into the lobby. But maybe or we can have the login screen itself say, oh, we've already logged in. The authentication manager says we already have a user. We'll just relog in with this token. Either way, though, the initialize method is going to load the login scene, and then it's going to connect to the transport, because we want to make sure the login scene is entirely loaded before we connect to the server. Because remember, the server is going to create a login system. Now, you're going to see in a little bit, we are going to actually have the login system be a game object that is added to the login scene itself. So we'll see that here momentarily. Okay, for initialize, we're simply going to return context dot, well, do I need to make that a property? I don't think I do. So we'll just leave it as is. Okay, so initialize will context load scene, and we'll just simply say login. And then I'm going to say then transport.connect. And then I'll say on success. And for this, we'll initialize the player. So on success, oh, okay, good. We can take in that. So on success, I'm simply going to initialize the player. Remember, to initialize the player, we need to tell the server what kind of thing we are. Because multiple kinds of things can connect to the server. For example, logging, reporting, automatic things, APIs, so on. So we need to tell the server we are a player. So to do that, I'm going to say var parameters equals new dictionary of byte and object. And then I'll go ahead and initialize this. I am going to be using the old style dictionary initializers. I am not going to be using the new style dictionary initializers, which are a lot nicer looking, but unfortunately cannot be used with this version of C# we're using. Okay, we'll do byte operation parameter, which comes from BuzzMMO base, dot what did I call that? Context type, and then we'll pass in a context type of context type dot player. Of course, that's currently the only context type that we have. Then I'm simply going to do transport.send operation, operation code init context, passing in our parameters. In fact, we can go ahead and just one-line this whole thing. That looks a little cleaner. Okay, so I hope you guys are starting to see again, I gush about this all the time, but the power of the deferred API. We can chain in all these asynchronous operations very easily. So we load the scene asynchronously. Then we connect to the transport asynchronously. But until we're connected to the transport, we don't send it anything. But then once we do connect, we go ahead and print this out. Now, I'm not doing an on-failure callback here. You guys can if you want to. The reason I'm not is because our Photon client transport already logs out an error if it got an error connecting. But you might want to say, like, on fail, show an alert dialog box saying, oh no, we can't connect to the server for blah, blah, blah reason. But since we don't have the system or the thing in place that I'm going to be using to create dialog boxes and stuff, I'm not going to worry about adding it in here. And then destroy is simply going to be return transport.disconnect. And that's it. So now we need our systems. So I'm going to go ahead and create a systems module class. So I'm going to come up here to code, and I'm putting this, well, I could put this in infrastructure as well if I wanted to. Yeah, let's put it in infrastructure. Let's do a systems module. Now, the systems module is simply responsible for accepting a transport and connecting all of the systems things together. So, yeah, we're going to have a, first of all, we're going to create a constructor that takes an I client transport. And then we're going to create a couple public properties here. We're going to do a public component map, which we should be familiar with that by now. And we'll do a, well, do we want the component map there or not? I think we do. Do we? Yes. Yes, we do. Then we want a Unity system factory. I don't know why I'm making these public. I think I needed them at some point in the future. System type registry. And I think that's it. Oh, of course, we need our systems. So public client systems. So those are all of our dependencies. We're also going to need a serializer. But I think instead of taking the serializer, I'm going to take in the game context. And it's kind of ugly to take in a game context like this, like a huge object where we only need like one thing from it. But these classes are so coupled anyway. Pretty much everything is coupled to the game context. And I think I'm just going to leave it like this. Might bite me down the road. It is a bit of a code smell, but I'm just going to do it anyway. Okay, so for this, the first thing we're going to do is we're going to say type registry equals new type registry, or system type registry. And then we're going to do type registry scan assembly, passing in type of systems module dot assembly. Now, I'm not going to use this second overload here with the type filter, but I might expose that as a optional parameter of the constructor in the future. Then I'm going to do system factory equals new Unity system factory. And, oh, that's why I needed a context, because we need to pass into the Unity system factory. And then we're going to pass in the type registry. And then our component map equals new component map. Then we're going to need our operation writer is a new system operation writer, passing in our serializer, which is context.serializer, and our transport, which is simply transport. And then our systems is simply new client systems, passing in our component map, our system factory, our operation writer, and then finally, this is one of the most important parts, transport.add event reader, new system event reader, passing in context serializer and systems. So pretty much the reason I'm making this its own little thing, its own little systems module, is I didn't want to have to write this code over and over and over again. But the important thing is it goes ahead, it attaches itself to the transport, so we don't have to worry about attaching it elsewhere. And we can just go ahead and instantiate it from our master server, and we have our systems. So let's go ahead and do that. Jump back to the master server. I'm going to create a public system module systems, get private set. And then right here, I'm simply going to say systems equals new system module, passing in our context and our transport. And there you go. Now, at this point, we should actually be up and running. So let's go ahead and hit F6, make sure we don't have any compilation errors. And we do. We had a couple warnings, but I think they went away. Whatever. I'll jump back into Unity. Oh, here we go. Log is never as assigned, and the private field context is I don't care about either of those. Okay, so I'm going to go ahead and launch my log viewer and Photon. So let's go ahead and get that out of the way. I don't care. I'm not going to be connecting 20 times. Yeah, I haven't got my license added yet. I need to do that one of these days, but it's just kind of been too lazy. Okay, so let's go ahead and make sure we have the right logs open, and we do. So the service is running, so we can go ahead and clear out everything. And yeah, let's go ahead and hit play. And we have some problems. First of all, we're not in a scene. We want to be in the loader scene. Second of all, we need a login scene. So I'm going to go ahead and create a new scene called login. And make sure it's saved out. And then I'm going to jump back into the login, and I'm going to go into build settings, and I'm going to say add open scene to our scenes in build, otherwise it won't load. And then I'm going to go ahead and hit play on, whoops, this is login. I want to go to loader and hit play. And, well, we got pretty close here. Ooh. This is the actual error I was getting when I had the mismatched Photon versions. The reason why the Photon versions didn't get updated was I hadn't done a build since I copied those DLLs. So I'm going to go ahead and open up our project here and hit F6. That should go ahead and copy out. Well, maybe just to be certain, I can come over here. Well, actually, to be absolutely certain, I'm going to open up this assemblies folder, and I'm just going to nuke every single thing. Now we get a bunch of errors. Then I'll jump over into BuzzMMO, right-click Unity, and hit Build. So that should go ahead and copy all those assemblies back in. Now hit play. And check that out. We are in the login. We are in the login scene, and we are in the all that stuff. We are connected. So let's go ahead and jump over here and jump into our master just to absolutely test everything. On awake here in my login system, let's nuke evoke count. I'm going to simply say proxy.debug set available players new, and then new user details 1 admin new hash set. Come on, you can do it. String, and we'll leave that empty. Then I'll hit F6 to recompile. Make sure that we get a restart here. And we do. Bleh. I should probably change that. Come back into client. Reload this guy. Jump over into our login system. For our debug set available players, I'll simply do... actually, I want to use log4net for this. Private static read-only log equals log manager get logger type of login system. A lot of logs here. And then we're going to do log.info users at 0. Come back here, hit play. Let's see if that works. And we're not getting any information there. So the reason we're not is because my game manager does not have don't destroy on load set. So when we move from the game context, when we move from scenes, it gets destroyed. So we need to go ahead and resolve that. Jumping back into client, I'm going to jump into game context. And then up here on awake, I guess I guess on awake, I'm going to go ahead and say don't destroy on load game object. So the game context will not be destroyed on load. All right, let's try this one more time. Hit play and check that out. Player 1 admin is sent to us. So everything is working and everything is awesome. Alrighty, there's one more thing that I want to do in this video, and I promise you guys, at least I hope so, really hope so, that this will be the last thing that we need to do before we jump into the actual implementation of our first system. And that is, I want to actually be able to create, over here in my hierarchy, I want to go ahead and just, create an empty object and call this login system and maybe move him into the top. Can you give these things colors? Does that show up? I forget. No, it doesn't show up in there. But, so there's no way to mark it. But anyway, I want to come over here into code, into systems, and I want to add login system to here. I also want to jump over into our client and then in our login system just to prove that this is going to work. Well, it's not going to work now, but it'll work after we fix this. Public string stuff. And I'm simply going to say log info stuff. And what I want to do is I want to come over here and I want to be able to, on this stuff, say, hello world. Now, the reason I want to do this is I want to be able to construct my systems as game objects inside the Unity editor. I do not, just because our system is very, very dynamic and things change, things are created and destroyed all the time, doesn't mean that we don't want to be able to take advantage of the Unity editor. So for some of our systems, we want to be able to create the system within the Unity editor as a game object, but then have it kind of deactivated, sort of, at first, and then when it actually becomes used, go ahead and activate it and attach ourselves to that particular system object. So that way we can add references, like references to UI widgets, for example, and it makes our code a whole lot easier instead of having to be dynamic all the time. So let's go ahead and do that. This is going to be a really simple fix. We just need to jump into our Unity system factory and make some changes here. So the registered system, we'll go ahead and do that first, but then our system instance is going to be a little bit different. What I'm going to do is say, at the top here, I'm going to add a new line. I'm going to say unity engine.object.find object of type, and then registered system.concrete type as iUnity system base, and then I'll use the null coalescence operator to, in the case that it cannot find an existing object, to go ahead and instantiate it. The next thing I want to do is we want to be able to allow the system to do initialization after the setContext method is invoked on it. So I'm going to come up to my Unity system base tick2, and I'm going to change this a little bit. First of all, I'm not going to use the onDestroy method. I'm going to say public virtual. Instead, I'm going to make the dispose method virtual. And so if we want to do cleanup code, we'll do it by overriding the virtual method. And that'll allow us to do cleanup code before the destroy call or after the destroy call by calling base.dispose. Then I want to add a method here. I want to add a method simply, actually I'm going to do this down here. I'm going to say protected virtual void on connected. And it's simply going to be empty. And then on setContext, I'm going to say onConnected at the end here. So this way, instead of relying on onStart and onAwake inside of our systems, we can now rely on dispose and onConnected. The final thing, well, no, I think I'm going to leave it at this. There is one thing that kind of leaves a bad taste in my mouth, and that is when it connects to an existing system, it might not have don't destroy unload set. Now, this could be a good thing or a bad thing. It might cause an issue. I'm seeing this kind of as a code smell that might cause an issue where if we switch scenes while that system is still active, the system object will be destroyed and a lot of nasty things will happen. However, in practice, I'm not sure that situation is going to ever arise, so I'm not going to be too concerned about dealing with it. So anyway, let's jump back into Unity and hit play, and let's see what happens. So we hit play. Oh, well, we have to go into the loader, of course. We hit play. And what we get is we get hello world and our guy here. And if we open up these systems, we see the login system was not added to the system's game object, and it still is active on our login system game object. So now we can configure and create systems inside the Unity editor and have them connected to our network code. But yeah, I think that's about it. So just to recap, we now have a very clear separation of concerns between our components. Our game context is kind of the root of our game. It has things like loading and unloading. It has the ability to switch between different contexts like different server managers between connecting to master server or region server. Then we have our connection managers, which are simply responsible for connecting to different servers and telling them about what the connection is. And then we have our modules. In this case, we only have one module at the moment, systems module. But in the future, we're going to have a module for things like actors and the world and simulation and maybe logging and debug and all that fun stuff like counters and stuff that doesn't go through the systems engine or system module. But we can reuse this module between different connection managers, which is pretty much the point. So when we write our game server, we can use the same implementation of the systems module that we did for our master server. And that's about it. We're now ready to go ahead and write our login code. So we'll see you guys in the next video.